Okay. So now I'm going to talk about the SGX. Kai did this work, and then actually I architected this one. So I'm speaking for Kai, but I worked with him for enabling. So I'm pretty knowledgeable around this one. So okay. First of all, I would introduce quickly what the SGX does and what it is, and then followed by how we're gonna enable SGX on Xen. Okay. So what's the purpose of SGX? What it really wants to do? So this is a key foil actually. So the point of SGX is don't trust basically hardware. I don't know, trust the hardware. Don't trust operating system or even VMM, okay? Only trust your enclave. So you trust the hardware and enclave. I'll talk about enclave more, but it's essentially the link 3 component within your application, okay? So this way, even OS or VMM are not really malicious, but sometimes, attacker can use exploits, right? To use OS or VMM to attack application or VMs to steal, sensitive information or data. So that's the reason we have SGX, okay? So far should be clear, right? Okay. So what it actually prevents is whatever the snoop in the bus, memory bus, or the system memory, memory, and we have a special memory for it, in enclave. And within the CPU package, the data is not encrypted, it's clear, but if you look at the system memory side, it's all encrypted if we use enclave. So whatever data transfer in the system bus will be basically prevented, okay? Now I'm talking about the enclave. So this is a little bit complex, but the idea is simple. So enclave is trusted execution environment within the application. So this is one kind of issue with the SGX, but you kind of need to modify or refactor application to enclave. And in enclave, you basically do your secret stuff, right? So if you have sensitive information or doing some confidential things, then you create an enclave and you do that kind of thing in the enclave. In the enclave, you can have a data, also the code, and then the stack, okay? That kind of thing, okay? This one. And there, all the data or the code will be, protected by, again, hardware. Even OS or VMM try to see the content, you cannot really see, okay? And you have you can have a multi, threads there, and then I'll talk about how you're gonna enter the enclave from application. Okay, there is a new instruction set for enclaves. Okay, and enclaves are mapped to special type of a physical memory for encryption, which is called EPC, enclave page cache. Okay, this one, right? And then this is reserved at boot time, And then today, on the Skylake, it's actually already enabled. So for example, some configuration of Windows actually uses SGX already. And typically, the size of EPC is not large, like a 64 megabyte, okay? On the servers, you may find more EPC, okay? And we, like I said, we extended architecture to have supervisor level, supervisor and then user mode. This is just kind of a kind of prefix. So there are a lot of operations. For example, create, enclave, or destroy, that kind of thing. And so those are new instruction set to handle the enclave. One thing note about that enclave environment is, even though this is a Ring 3, we wanted to make sure the environment is even safer, okay, more protected. So we prevented some instruction that could be used as an exploit or attack. For example, like CPU ID is not available in enclave. Or even more, the system call, sysenter, right? This one, sysenter, syscall is not actually available because UD, okay? So how can you use, system call? Because, again, we don't trust operating systems. So there is no point of doing a system call, right? That's the reason we prevented. In SGX1, we even prevented the read TSC because sometimes TSC can be tweaked or cheated. For example, like a replay kind of a thing, and then we actually that was prevented, but because of a strong demand, and then we enabled read TSC in enclave in SGX2. Okay. And as you see the VM exit, so we can actually intercept SGX instruction for supervisor. Okay. Okay. Probably I should talk about exit and interrupt. So even you get VM exit, register contents or even the VMCS are saved into the enclave, okay? And register state are not really visible to even the VMM OS. Okay, so when the OS or VMMs look at the register value, okay, they are actually synthetic, basically 0. Okay, so the VMM or OS have no clue about the contents of the register. And when for example, VM entry resume happens, then the processor basically restore the state from enclave. Again, that's encrypted area, right? Then back to the enclave. Okay, but in that case, software doesn't need to do anything. It just from a VMM hypervisor's point of view, you just see the VM exit and some reason. For example, we need to take care of EPT violation, actually. And in that case, you get only the necessary information to handle the EPT violation. But you don't see that the register contents at that time. So this is a software flow. How do you enter the enclave? Okay. There's an instruction to enter here. You basically create the enclave, and then you call this one, and then basically which does is you need to have a driver, SGX driver in the operating system, and then what the SGX driver does is basically map the enclave virtual address to real enclave EPC. That's what the SGX driver does. Then once the process enters the enclave, it just kind of visible from OS or hypervisor's point of view, and then just return. You could have some shared memory. For example, you give some data to this one, but again, you don't trust the operating system. So whenever you pass information, you probably need to encrypt or do something. Okay. Inside enclave, again, you can do secret thing without being monitored by the other entity like OS or VMM. One thing I should note is, in general, modifying application is not really easy, right? It's not really sustainable because if you need a SGX, you look at all the application and then modify them. That's not sometimes a scalable approach. So there are some kind of research project where they run, for example, container, the entire container in enclave, okay? In that case, you don't need to modify the applications there. And what the infrastructure does is basically create a huge enclave and enter the entry point, and where then it start running those applications entirely in the enclave, okay? But like you saw, for example, system call are not available. So upon a system call, it generates, for example, UD, right? So the OS need to intercept the UD, and the infrastructure, the framework needs to do some system call for that enclave, then return back the result back to the enclave, in this container. So you don't necessarily to modify all the applications to enable SGX, right? Like I said, you can have some infrastructure to run container, entire container within enclave, okay? That's kind of happening today. Now, so how we're gonna enable SGX in Xen, okay? Some part is straightforward. It's essentially you advertise SGX using CPU ID and MSR. Some the SGX specific MSR. Then EPT, what you need to do in the Xen side is, in the EPT, you just simply point to the EPC page. That's it, okay? You don't need to do anything special for that part. So up to this point, it should be straightforward, and when you get the VM exit, again, like for example, the interrupt or whatever, then it just normal VM exit. Although the contents are modified, tweaked by the hardware, like I said, it's a synthesized VM exit. So all the values are basically hidden fake, right? It's 0. Only thing is, for example, VM exit reason will be, of course, valid. Okay. Now it's not very tricky, but the only challenge is EPC by virtualization. Like I said, EPC is limited. So on the native side, where you have basically only one operating system, so even you have an application, probably you can have probably sufficient EPC, but on virtualization where you have more than one VMs, then you could have a more demand for the EPC, right? So there are ways to, it's not really virtualized, but how you're gonna, provide EPC to guests, okay? So we have 3 options, and then actually we did a POC for all of them, okay? Oh, and then one thing, I think I will cover this one. There is a new VM exit, and I'll talk about the options later. Okay.
We're already at time, by the way.
Okay. So this is a very quick view of architecture, right? So you have EPC here. EPC, and then hypervisor need to basically either partition or over subscription or use ballooning for EPC. And those are the options. Okay, so static, it should be easy. It's limited, right? Because the total amount of EPC is same as platform, ballooning, and over subscription. And I don't think I can talk about the details of this one. I think I want to talk about the design session, how complex, how we're doing here. But I just wanted to show the options for the EPC virtualization. Okay. So with that, I think I'll like to take questions if I have time.
I don't think we have any time for this. Again, there is a design discussion this afternoon scheduled for this.
That's fine.